Let f of x equal to x squared. Find f of x plus h. B. F of x plus h minus f of x. C. F of x plus h minus f of x divided by h. And then hence find the gradient function f dash of x using f dash of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. So we've got f of x is equal to x squared. First of all, we're asked to find f of x plus h. So that means instead of x in here, I now put x plus h. Now to expand a plus b all squared, you need to use the binomial theorem, which is x squared plus 2ab plus b squared. So applying that to this, we're going to get x squared plus 2xh plus h squared. Part B, f of x plus h minus f of x. So that's going to be all of that minus x squared f of x, which is x squared. Obviously the x squareds cancel out, and you're just left with 2xh plus h squared. C, f of x plus h minus f of x divided by h. So the numerator is going to be 2xh plus h squared divided by h. Now on the top here there is a common factor of h. Now you're strongly advised to factorize rather than trying to cancel straight away. So factorizing out, we get h 2x plus h divided by h, and then the h's cancel out, and you're left with 2x plus h. Now there's one condition about that cancelling, that h is very, very small, but not actually equal to 0. Now in order to find the gradient function, you need to take the limit of this function as h goes to 0. So it's the limit of f of x plus h minus f of x divided by h. And this is called differentiating from first principles. So we want to do the limit as h goes to 0 of 2x plus h. Now what you've got to say at this stage is that h is so small that you can ignore it. So you're just left with an answer of 2x. And the reason is that h is infinitely small. So what we're saying is, if we got f of x is equal to x squared, then the gradient formula, or the gradient function called f dash of x, is equal to 2x.